Right. BGP backdoor. In what situation you need this BGP backdoor? You have an autonomous system connected to two other autonomous systems. For some reason, you have EIGRP here and EBGP here. So what happens is, because of the administrative distance, the router here, I'll call it as router 1, router 2, router 3. Because of the administrative distance, to reach a network here, where? Here, 2.2.2.2. To reach this network 2.2.2.2, router 1 takes this long route. Can someone tell which route it will take? Will it take via router 3 or router 2? I already gave you the answer. Because of the administrative distance, router 1 takes this route, which you do not like. Why? Because it's a long route, 2 hop away, 2 autonomous system. This is easy to reach, but unfortunately, the administrative distance in the routing table here is 90. For this, it is only 20. This is where you will use backdoor. You will tell router 1, in order to reach 2.2.2.2 network, 2.2.2.2, use backdoor. That's all you will say. As soon as you say this, for that network alone, router 1 will make administrative distance as 200 locally. Even though it is learning from EBGP, it will say it's not 20, it is 200. As soon as router 1 makes it as 200 administrative distance, it will start using this path. Did you understand? Or do you have any question? Why you take so long to answer this? All right, let me repeat. From the beginning, don't worry last. I'll start from the beginning. It's a simple concept, small concept, easy to configure, not a big difficult topic. So I can repeat it for you again. Listen. Router 1 has got 2 source learning 2.2.2.2. It learns from EIGRP. It also learns from EBGP. The router 1 routing information base learns the same network from 2 sources. Now, routing information base needs to decide one and drop the other one. Needs to decide to use one and drop the other one, for which it will use the administrative distance as a tie break. The route that is coming via Ethernet 0 is coming with the administrative distance of 90. The route that is coming via the serial 0 is coming with the administrative distance of 20. Now what R1 does? It chooses to go via this way, which is not a recommended path for you because it's too far, 2 hops away. Instead of going like this easily, it is taking a long route which you don't like. And you want the traffic to go via the easy way, not the long route. So what you do is you go to R1, repeating again. You don't go to any other router for this. You go to R1 because R1 is the problem. R1 is what taking this path. So you need to go to R1 only. Don't go and do anything in R2 to achieve this. Just go to R1. R1, use the backdoor. That's all. R1 for the network. 2.2.2.2. Where you type this command under BGP, you type this command to this network 2.2.2.2 backdoor. As soon as you use this keyword backdoor, what it will do, it will make the administrative distance as 200 instead of 20. Even though it is learning from an EBGP neighbor, even though the route is coming from an EBGP neighbor, automatically the administrative distance will be given 200. You no need to mention 200. It will be dynamically allocated. It will be dynamically changed from 20 to 200. Now RIB, what it will do? RIB will say, I don't want your path. Let me go via the green path. Green path, shortest path. Did you understand this? Or do you have any question? That is what called as backdoor. That's the power of the command backdoor. That is what the command backdoor will do. You no need to give 200 because BGP knows only two numbers, 20, 200. So if you say backdoor for the 20 network, the other option that it has got is 200 only. All right, now I'm going to show you this quickly. Yep. What's the question? Ask again. I fear to say that you misunderstood RIP failure. First of all, you have to understand what is RIP failure. And then we will come back to this one. I'll answer your question, but you have some problem in RIP failure. When will I have RIB failure? When I'm not able to use BGP. When I'm not able to use BGP routes because there is some other route like static route or some other route like route coming from a protocol whose administrative distance is less, not more, less. Some other source giving administrative distance less. In this case, it is totally opposite. Administrative distance was 90 more and 20. The scenario is totally opposite. So, in short, I want to say backdoor is not used in RIP failure scenario. No. Answer is no. What is RIP failure? When you have IBGP, not EBGP, when you have IBGP, routes will come with 200 administrative distance. And I have EIGRP, routes will come with 90 administrative distance. So both are advertising a network called 1.1.1.1. Now router BGP says, R1 says, RIP failure in BGP table. Why? For router 1, the administrative distance of BGP is higher. So router 1 cannot use 1111 route given by BGP. It uses EIGRP is 11111. This is what called as RIP failure. Is this clear? But backdoor is opposite. So backdoor is EBGP is 20. It will go via EBGP, which you do not like. You want EIGRP path for some reason. I gave you one example here why you want to go via EIGRP path. You may be having some other reason also. So you want to avoid, or in another word, you want to create a RIP failure intentionally. Actually, it won't be called as RIP failure. I'm just telling you so that you will understand. You want to ignore BGP path. For that, when you say backdoor, this 200 will be converted as 20 will be converted as 200. Automatically, BGP avoids using BGP path. BGP itself is taking this decision. BGP avoids using this path, and by making it as 200, making it as 200, and now it cannot show as RIP failure because it is intentionally doing it, making it as 200, and EIGRP, whose administrative distance is 90, is going to be used by routing information base. Let's do this and see. All right, see, I'm going to use a notepad to finish this configuration really quick. So notepad, enable config T interface loopback 0 11 and then interface G1/0 200.12.0.1 interface serial 3/0 100.13.0.0 and then I would like to run EIGRP autonomous system, let's say 10, and I'll advertise the network 200, network 11. Also, I'll say router BGP 100, neighbor 200.12.0.2, remote AS 300. Network I want to advertise is same 11, mask, in EIGRP I have to say no auto summary. There is also another neighbor to advertise, neighbor to form, neighbor. Yeah, so that's it. Copy, paste this under one. There's nothing more here. We finished. Next. Router 2 has got 22. G01 has got 10 has got 2 here. and serial 3/0 has got 32. What am I doing? 200.32. And this is going to be 2. And now next is I'm going to run EAGRP 10 here also. 10.12 is correct, and then the network that I would like to advertise in EAGRP is 22. And the same network I'll also advertise in BGP, so 22 here also. And then 10.12.0.1 neighbor, 100 is the autonomous system number, and 300 is the autonomous system number here. I got another neighbor 200, 32. That's it. This is on router 2. Next, serial 3/0 will have 100, or let me make this as 3/1, which is on the right hand side, router 3, 0, 3. And this I'll change it as serial 3/0. And IP address will be 113.3. So we got the loopback, we got the two physical interface. We got the loopback, we got the two physical interface correctly configured. And now we don't need EIGRP here. We remove this EIGRP from here. And we put BGP. BGP 200.13.0.1, which is in autonomous system, not 200, it's 100. The autonomous system is 100. Next. The network that we want to advertise is 33. Mask is this. And then the neighbor, the other neighbor is 32.0.3, not 32. Who is in autonomous system 3. The autonomous system local is 3. 2. Router 3. Let's paste this. I'm expecting 2 eBGP now. Show IPBGP summary. ping 100.13.0.1. There's a problem. R1 show IP interface brief. The interfaces are up, but this is what I made mistake. See, you have to correct me when I'm typing. Sometime I may type. You're keeping silent until the end of the class. That's not correct. You also need to help me to finish serial 3/0, IP address 100.13.0.1. I'm doing this lab for you. You know it. So you need to correct me when I'm typing wrong. So I got one neighbor, show IP BGP summary. There is another neighbor that I want, but it's not appearing, show IP interface brief. The IP address on 3/1, 200.32.0.2, sorry, 0.2. That's the mistake. See, it should be 3 on router 3. 2 is already given on the other side. Interface serial 3/0, 3/1. Yeah, interface 3/1. IP address is 200.32.0.3. Show IP BGP summary now. Ping 200.32.0.2. It pings, but show IP BGP summary. I'm not able to see, so there's some problem in configuring BGP. Show run section router BGP. I did not configure a neighbor. A neighbor is missing. Router BGP 200. Neighbor is 200.32.0.2. Remote AS is 300. Show IP BGP summary now. See, neighbor has come up. Yep. All right. Let's begin our backdoor. On R1, I must see to show IP BGPs. So, we got BGP. See, we are learning two routes. What are those two routes, Show IP BGP. We are learning route like 22 network from two different sources, 33 network from two different sources. But it says for 22, I'm going via autonomous system. Oh, I made a mistake. We should not run BGP here. Let me remove that BGP. Router BGP backdoor will be applicable only if you have yes. Yeah. See, the scenario is for some reason you are not allowed to form BGP between that autonomous system. This is very common actually. You will have a WAN connection. This is like a WAN connection. Over the WAN connection, meaning like frame relay tunnel or MPLS layer 2 tunnel, you're now forming a EIGRP relationship over the tunnel. So instead, you expect traffic to go via the tunnel. That's why you created the tunnel. But the traffic is not going via the tunnel. It is using EBGP path, which is IP path, not the MPLS path. So instead of because we have not gone to MPLS, I'm just making it as one EIGRP link. Usually, it used to be an MPLS link, layer 2 tunnel, using which we call it as VPLS, using which we negotiate EIGRP. Or you may even have DMVPN or site-to-site VPN or GRE tunnel, via which you negotiate EIGRP. Yeah, it can be even OSPF. It can be even RIP. I'll change OSPF after I finish EIGRP. I'll change OSPF and show you. No RIP. Yes. Now I have removed EIGRP. Sorry, BGP, show IP BGP summary. I got only one neighbor. This is what the scenario should be. Show IP BGPs. So there should be only one neighbor. Now let us check show IP BGP. You are learning the 11 network via router 3. Not straightly via. Let's check EIGRP neighbor. Show IP EIGRP neighbor. There is a neighbor show IP route EIGRP, but there is no route, so there is some issue with the EIGRP. Show IP protocol. I'm seeing EIGRP. EIGRP is advertising a summarized route. No. We want a detailed route. That's the issue. Router EIGRP 10. No auto summary. Likewise, I'll go to router 1. Router EIGRP 10. No auto summary. So we are intentionally making show IP BGP, show IP BGP, show IP route EIGRP. So we are not learning route EIGRP. You know why? The administrative distance. See, but the topology table will show you show IP EIGRP topology. Topology table shows you 22. But there is no successor. Why it is not successor? Because this is not fulfilling the RIP, routing information based requirement. Administrative distance is higher. That is why inaccessible. Even though this gateway is pingable, you are not able to use it because of the administrative distance. EIGRP gives, but routing table is not accepting it. Why? Because the administrative distance of EBGP is less. So you see 22 via B because of this administrative distance. So it goes to router 3, router 3 will send it to router 2. So if I trace route now 22.22.22.22 with the source 11, 11, 11, 11, it goes via 2 hops, means it goes via router 3. But when I make it as backdoor, see what happens. Router BGP 100. Network. This is the command, network. See, this network belongs to other autonomous system, but you have to use the network command. Usually network command we use to advertise our own network. But for backdoor concept, you have to use for someone's network. For someone's network, for autonomous system 300's network 2222, I'm saying backdoor. That's it. How easy, you see. I'm saying backdoor, meaning don't consider EBGP. Now let's go and check. Yes. You need to, yeah, for all the networks. So now I'm going to say show IP BGP. Now, even though you see like 22, 22, 22, wire out of 3, valid and best, show IP, route EIGRP. Oh, come on, even now it has not come. I think there's some issue with the EIGRP. Show IP EIGRP topology. The reason is the mask. Very important is the mask. BGP will always try to match with the mask. So what I should do is the network command will always try to match with the mask. I should have said it's not slash. When you don't say mask 8, it will if you don't say mask, the exact mask it will say 220000 because 22 is class A. So we need to specify. We have subnetted there /32. So I need to say network mask 255. Only if all 32 is matching, then use backdoor. All right, after saying this, show IP BGP, I should see now RIP failure. I'm creating the RIP failure intentionally. I'm not changing the RIP failure to something else. I'm not using backdoor to solve RIP failure. I want RIP failure. So that EIGRP will be used for 22. You see, EIGRP is used. 90 is used because that is administrative distance 200 now. Show IP route BGP 22 22 22 22 slash 32. You see, not route, cut the route off. You see, it says RIP failure. And it's best path, also valid path, best path, even though it's valid and best, unable to use because we use the keyword RIP failure. But I want to show you that it will change the administrative distance to 200. But this output is not showing. But it is because of the administrative distance. You know very well, the default administrative distance is 20 for EBGP. And EIGRP is 90. If you will see EIGRP 90 in the routing table, it means the administrative distance is something bigger than 90 for this network now. Actually, it will change it to 200. Through some commands, we can see show IP BGP RIP failure. See higher administrative. This is the maximum proof I can show you now. For 22, it is no more 20. It is higher, meaning it is higher than 90. Yes or no? Of course, it is higher than 90. Otherwise, EIGRP cannot come. It is 200. See, BGP knows 20 and 200. After 20, it knows only 200. If it is putting higher, then it will put 200 only. But who cares whether 200 or 100? It is higher than EIGRP. Now let us change this to OSPF and see. I'll remove EIGRP, no router EIGRP. Okay, before the let us trace route. 22, 22, 22, 22 with the source 11, 11, 11, 11. So it goes one hop away, just one hop. You see? So backdoor is over, but for your question to answer, I'm going to change OSPF. Router EIGRP 10, no. Router OSPF 10, network. Let me use loopback configuration. Interface loopback 0, IP OSPF 1, area 0. Interface G1/0, IP OSPF 1, area 0. Let me remove the OSPF 10, no router, OSPF 10 not needed. Okay. So show IP OSPF neighbor, show IP OSPF interface brief. These are two interface. Show IP EIGRP neighbor, no EIGRP. Show IP EIGRP interfaces, no interfaces. Alright, I removed EIGRP actually. Going to router 2. No router EIGRP 10, and then interface loopback 0, IP OSPF 1 area 0. Now before I configure the other interface, I want to show you now it will go to hop away because we removed EIGRP. There is no more RIP failure here. It goes via 2 hops. There is no more RIP failure. Show IP BGP. No RIP failure now. Yeah, no RIP failure. It goes via 2 hops. Interface G1/0, IP OSPF 1 area 0. Now you will see OSPF never coming up. Okay, good. And now going back and check one hop. Check BGP, RIP failure, higher administrators. So you may have any IGP protocol. I tell you, it is going to use that IGP protocol instead of ABGP when you configure backdoor, right? So 200 is what the number. See, this OSPF has got 110. If an administrative distance need to be higher than that, then why you are not accepting 200? Accept it. 200. I tell you. 20, 200. It knows only 2. If you say don't use 20, it will use 200 only. And I'm not able to show you as an output, but that is what the actual thing that is happening behind the screen. But in some iOS, we can see that when you type that command, show IP BGP 2320. I'm not able to see that is the RIP failure type. RIP failure because of backdoor. That's what that 17 means. Things that we need to focus on route reflector is the cluster ID. Cluster ID. What is cluster ID? The router ID of the route reflector server is what called as cluster ID. Repeating again, the router ID of the RR server is what called as the cluster ID. So if you have multiple route reflectors in your autonomous system, to know from which route reflector this route got learned, we check the cluster ID. See, when there are multiple route reflectors, to know from which route reflector we have learned the route, this router has learned the route, we use the cluster ID. That is one thing we need to know. Next thing is, as we all know already, route reflector is reflecting the route to the IBGP. there is a default rule called, the route that is learned from an IBGP. What relationship between this R1 and R2? IBGP. See, it's within the circle. Let's say autonomous system then. A route learned from an IBGP will not be given to another IBGP. Will not be given. But we make it to give by saying to R2, R3 is a client, route reflected client. When you say that, R3 learns the route with a cluster ID 2.2.2.2. Right? So router 2's router ID is 22222. So all the EBGP learned route comes up to router 2 and router 2 reflects it. So router 3 will say, I'm learning this route because R2 has reflected it. R2 is my cluster. I am a client for R2. He is my cluster. He is my uniting glue. He is the gum between me and R1. If not R2, I am not there. It is R2 the one who advertises the control plane, meaning the route information to me. I belong to him. We are one cluster. Router 3 says, I am a member of the cluster, Mr. Router 2. I am his client. All right, now, boom, boom. There is another router here, R4. There is a network coming from here, beta, 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 beta. The network coming from here is alpha, alpha, alpha. To learn alpha on router 3, you made router 3 as a client. Now for beta to be learned, what I do is I make this as a client and this is a server. So I go here and say router 2 is your client. So router 2 says I learned beta from the cluster ID 3.3.3.3 and I learned alpha from the cluster ID 2.2.2.2. So both are servers as well as client. So how many cluster IDs you have? 2. So how do you know from whom you received it? How router 2 knows whether I am receiving from R4 or R2? By checking the cluster ID. Why? By default, when router 4 advertises, it will not. It will put its own address. If you say next up self here, it will put its own address. R3 will simply carry the address. R3 will not put its own address. R3 will not put his own address. R3 will simply forward. Then how R2 knows I am learning from R3? How R2 knows it's been reflected by R3? Cluster ID. Right, this is one main story of RR which not many people focus. Instead of focusing on this, they focus on another small thing. Let me explain that small thing now. Are you clear with the cluster ID? Now let us go to something important. Sorry, this is important. Let's go to something which many may know about RR. But that also 90% of people don't know, which I'm going to teach now. See, alpha, 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 alpha is coming. It is now reflecting in R2. R2 will not give because of IBGP split horizon. It says route learn from an IBGP, don't give to other IBGP. So what I do, I go to router 2 and say R3 is your client. So R3 now learns about alpha, 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 alpha. with a cluster ID. Now, one good news is this beta that is coming here, comes here. It will come here, beta. But I have not configured R2 as a client. I have not configured R2 as client. Not. I have not configured. Then how beta only comes to R2? That is what called as passive client. Listen. No. Sorry, this is not the scenario for that. Okay, so wait. This is what actually I mean. Here you will say R2 as a client. Okay, now coming back to the story. From the beginning, R3 is a client to R2. R2 is a client to R3. Is this part clear? R2 is a client to an R3. R3 is a client to R2. Is this part clear? Oh, come on. Right, thank you. Now, is R1 client for anyone? No, but still, it can learn beta. Is R4 a client for anyone? No, but still, it can learn alpha. This is what called as passive client. Here is a server. This is actual client. Whatever this R1 advertised, it was given to the client. In return, whatever that is given by the client, whatever is coming from the client side will be given to this client. Wait, let me put it in an easy way. R2 gave whatever R1 gives to R3. So now R2 has a responsibility to give whatever R3 gives to R2 to R1. That's it. What is passive client? Even though you have not made R1 as a client, even though you have not configured R1 as a client, R1 will still learn. R1 will still learn the root. Without knowing this, what people do, they make this as a client, also this as a client. This as a client, also this as a client. No, I'm saying not necessary. You only make these two as a client, it will work. Make this as a client and this as a client. Finish. R1 and R4 will be passive client. Route learned from a IBGP. See, route learned from an IBGP will be given to a client, and if you have another router here and EBGP, it will also given to EBGP. And if you have a IBGP, acting as EBGP, this becomes a passive client. It will give even to this one. Right? So that's about RR. The configuration command is very simple. You need to go to router 2 and say neighbor. Router 3's address, say for example 3.3.3.3. Route reflector client. Don't put RR client, type fully route reflector client. This is your homework. You do this lab, it will work. You do this homework, and if you really have any problem, bring it to me, I'll fix it. I want to see you working on this topology. Take one autonomous system here, advertise the alpha network. Take another advertise. We don't have. Test this. Go to router 2, make R3 as a client. Go to router 3, make R2 as a client. That's all. Just 2 line of command I'm asking you to type. Nothing more. So if it is really needed, I will do it in the next class. We have covered 2 topics today, router reflector and backdoor. The remaining topic in BGP will be BGP configuration, which is going to be only theory. BGP community, we will do the lab same like what we did today. And BGP dampening, we'll do the lab as we said today. And this one will be theory only. You have to do that homework. It is very easy. That's why I'm giving us homework. So these things will be finishing by tomorrow.